Look at the laws of logarithms, okay? So we briefly talked about the power law before, but let's actually go through them. In order for these laws to be fulfilled or to be able to use them, we need the a value. So our base of the log needs to be greater than 0. The x value, so the number that the log is 2, needs to be greater than 0. And the y, that's both the x and the y. And the a value also is not equal to 1 in these instances. Okay, so the product rule states that our log base a, and we have x times y, can be rewritten as log base a x plus log base a y. Okay, so essentially just think of it as the two numbers that are multiplied here can be separated into their own individual logs with the same base. Okay, the quotient rule or law is log base a, and we have the values of x divided by y, can also be rewritten as their own logs to the base a of x, and then we subtract log base a y. And then finally, the power law is what we talked about the other day. We have log base a. When we have x to the power of r, we can just bring that r down in front and multiply by that value of r and keep the log the exact same. And that'll be very helpful when actually trying to solve for exponent rules. Okay, so let's go through a couple of these examples using these laws. So the very first one, slow down there. We have log base 3 6 plus log base 3 4.5. Okay, so this is separated, and without a calculator, if I was to solve this, I would know that the easiest way would make this some base of 3, but there is no simple base of 3 that is equal to 6. It's clearly 3 to the power of some decimal value, and the same idea with 4.5. So let's actually revert or change this into actual multiplication. So I know, since that the bases of the laws or the logs are the same, we can write this as log base 3 6 times 4.5. Okay, and we'll see if that helps us out at all here. So 6 by 4.5 is equal to 27. I now have log base 3 to the 27. Can I write 27 as some base of 3? What can I write it as? That's right, 3 to the power of 3. And if you remember what we talked about before, just enough room. If we have this relationship, we know that it's essentially equal to whatever the power is. So these log base 3 and the base of 3 can kind of be canceled out, and our answer is just 3 in this case. Okay. Same idea with our second one. Our second one, again, we're going to subtract. I would try to make 48 some exponent base 2. Again, I'm going to end up with some decimal or fractional value. So let's actually try to divide these values. We'll write them as both log base 2, 48 divide 3. Anyone know what that equates to? 16. Good. Can I write 16 as a base of 2? Yeah? What is the base of 2 for 16? 2 to the power of 4. Excellent. What happens next? Yeah, these two cancel out, and you're left with the value of 4. Excellent. Okay, here we have log base 5, and then we have the third root of 25. Third root of 25, going to be some decimal value, right? So let's actually rewrite this as an exponent. Log base 5, 25 to the power of a third. Okay. According to our power rule, we can bring the third down in front and multiply it by a third instead. When we do this, I now have just 25 within our log. Can I write 25 as a base of 5? All right, so let's write it as a base of 5. We have a third times log 5, and then 5 to the power of 2. Just like before, these cancel out into just the exponent, and we have 1/3 times 2. I apologize, I didn't write any equal signs anywhere, but we'll end up with 2 over 3. Okay? Okay, the toughest question. Okay. Question here. Log base a to the root of x cubed times y squared divided by w, and they want us to express it as a log base a with x, log base a with y, and a log base a with w. Okay, and we are not in that form as of right now. So the very first rule I'm going to use is I'm going to use a power rule. I'm going to change this. I'm going to change this vowel or this base here into the power of 2 because it's a root of 2. So we have x cubed times y squared over w to the power of a half. That power of a half with our power rule can come down in front, and we have 1/2 times log base a. And then we have x cubed times y squared over w. Okay, so here's our first step. I can then, because this is a division sign, I can use the quotient rule to split this into two separate logs. So we have 1/2 multiplied by log base a of x cubed y squared, subtract log base a of w. Okay, so what we did there is, because this was division, okay, I was able to write the numerator and denominator as two separate logs. I used the numerator, our x cubed times y squared, and I subtracted it by the denominator, which was just our w. Okay, so our w is already written as a log a with a w, log base a w. But here we're not quite at our parameters yet, and I need to finish this with a bracket. So I'm going to split this again. This is multiplication. Okay, so because it's multiplication, I can again split this function. Log a, I'm going to write it as x cubed. Okay, and because it's a product rule, we can write it as plus log base a of y squared, still subtracting log base a of w. Okay, so same idea. The only difference is we use the product rule. Because this was multiplication, we can written as two separate logs with just a plus sign in between. And then finally, these again, we can use our power law again to bring down these exponents in front of our logs. So we end up with 1/2. This will become 3 log a x plus 2 times log a y minus log a w. And the last thing I want to do, and technically this is written in that form, okay? We can expand it a little if they would like us to. We can distribute our 1/2 to the coefficients in front of each of these. Technically in front of this log, that's a terrible a. In front of this log base a w is technically a value of 1. Okay, so we're multiplying by the coefficient 1 there. So when we bring in that half, we're left with 3 over 2 log base a x plus 1, or we don't have to write the 1 in, we can just write log base a y, subtract 1/2 log base a w. Okay, and that'd be a pretty difficult example. We're using all of the laws and one of the laws twice, actually.